In these problems, we're using Cramer's rule to look at some systems of three equations. In this first one, all they want us to do is find the value of d sub y. So what we're going to do is set up the coefficient matrix, except we're going to have these values instead of our y coefficients. And then we'll determine the determinant of that. So let's set up that matrix. For x coefficients, we've got 1, 3, and 5. For y, we'll have our -3, 1, and 5. And for z, we've got 1, -5, and 1. And we'll calculate the determinant here. So I'm going to use the diagonals method, so let me copy the first two columns, 1, 3, 5, and -3, 1, 5. And we'll start multiplying on our down diagonals and adding those together. So that's 1 times 1 times 1 is 1. Let's see, 3 times -5 times 5, that is 75. And 1 times 3 times 5, that's 15. And then we're going to do our up diagonals and we're going to subtract. So 5 times 1 times 1 is 5. 5 times -5 times 1, that's a minus a -25. And then 1 times 3 times -3, we've got minus a -9. And let's see, that's 80 plus 25 plus 9. You're going to get 116 on that, I think, if you put that all together. Might want to double check. But that is our value of dy. If you wanted to know what the solution for y is here, you'd divide that by the determinant of the coefficient matrix. But they didn't ask us to do that. Let's look at the next one. Here it just says solve by Cramer's rule. So they're going to want all values for x, y, and z. Let's take a look at this. We're going to first determine big D, which is the determinant of the coefficient matrix, and then, assuming we can move on from there, because sometimes you can't, we'll determine dx, dy, and dz. So let's find big D by making our coefficient matrix. We've got 1, 1, 3, 2, 1, 5, and 1, -1, 1. And let me recopy the first two columns here, so 1, 1, 3, and 2, 1, 5. And we'll start multiplying down. We've got 1 plus 2 times -1 times 3 plus a -6 plus 1 times 1 times 5. And then we're going to subtract our up column. So we've got 3 minus a -5 minus 2. So I am getting this coming out to 0. And you might want to double check my work on that. But what happens when big D equals 0? Well, you can't actually use Cramer's rule to figure this out. One of two things is going on with the systems of equations. Either it's totally inconsistent and there's no solution, or perhaps it's a dependent system and they're all actually the same line. I don't think they're all actually the same line here. Doesn't look like it. So we're going to say that this is an inconsistent system. So if you get 0 for a determinant for big D here, you know that the system is either going to be inconsistent or dependent. That's a little bit of work with 3x3 matrices and Cramer's rule. My name is Larry. I'm a teacher at EdVision's off-campus. It's an online project-based school in Minnesota. If you're interested, you can check us out on the web at lovethischool.org. Thanks.